Yeah, hi everyone. So I thought I'd take an opportunity to show people how to analyze an ArduPilot crash dump. So Henry Wurzburg just had a crash on his F765 wing based aircraft and flying something close to master. It's a 2 or 3 weeks off master. And so he had a crash, and it turned out to be a watchdog, which is a serious issue. That means that the flight controller rebooted in flight. And I thought it'd be a good opportunity to show people how we analyze crash dumps and how you can then take the crash dump and work out what went wrong. So what we've got is Henry has sent me a log file. So here's the log file. This wasn't the log file of the actual crash. This is a later log file where he noticed he was getting a little message in Mission Planner saying saving crash dump. Because what we do, okay, okay, thanks, thanks, Henry. So what you can see, so when we actually, when a crash happens, so if something catastrophically goes wrong in the code or can happen due to power issues, when that happens, ArduPilot, what's called watchdogs, which means it reboots in flight when it just can't continue. It's used, and that can be, for example, a wild pointer, violation of memory access, all sorts of things can cause that. When it happens, we've got a little crashed up handler in ArduPilot, and it goes and saves as much of the state of the microcontroller as possible and puts it into an area of flash, which can then be saved to the micro SD card. And that crash dump file, then every time you boot the flight controller from then on until you have flashed a new firmware, will give you this little message, logging syscrashdump.bin. And so if you're getting messages like that, that means you have had a watchdog and it's putting the diagnostic information in this file, right? And you can then get the file. You can extract the file using Mav Explorer like this. So I could go and file crash dump like that, and that will save a file called cd.bin, which is a crash dump. Or you can get it off the micro SD card. It saves it into the APM directory, and that's what. So you'll see that these two files are identical, at least they should be. So if I comp cd.bin and crash dump.bin, the one in the log file is the same as the one that Henry got off the micro SD card. So this crash dump file is basically 427 kilobytes worth of the state of the CPU at the time it crashed. And because this is an F765, it's got a fair bit of flash free. And so if we have a look at our build list, our firmware ArduPilot.org build sizes, and many thanks to Michelle for creating this page, we see the plain F765 wing has 589 kilobytes worth of free flash. So we can actually save a really big detailed crash dump with the internal state of most of ArduPilot. Some of our boards have a lot less flash free, and so you end up with very small crash dumps, if any. You can see that, this one has 464 bytes worth of free, and some of them have a lot less. So how much we can save to the crash dump depends upon how much free flash. All right, so this is a good one because it's got lots of free flash. So now I want to show you how you take this crash dump and work out what went wrong in the code. What we want to do is attach a debugger to this crash dump so we can look at the state of the aircraft at the time the crash happened. All right, so what I've got is a branch here. This is just running this has just got ArduPilot master in it. I've got a little thing in bash that shows the current branch. And Henry has very kindly, if I branch -a or grep H Wurzburg, and he's created a little branch for me, H765 crash, which is the exact Git hash that he was flying. And that's important. So never fly a firmware unless you've got it in Git somewhere, preferably push to a server, because we need the exact Git hash to analyze a crash log like this. So I can check out that branch like that. And so now this is the exact code that Henry was running. And I can now update all the submodules to be the same. And what I need to do now is build this firmware with an extra option. So I'm going to WAF configure -board Maytech F765-wing. And I'm going to add the extra option -g. Now, -g is different to --debug. -debug is the normal developer one. And -debug gives you all the debug symbols, but it also changes the binary to turn off optimization and that sort of thing to make it more developer friendly. -g just adds the debug symbols. So when you build with -g, you end up with exactly the same firmware as you would normally get, identical in every way, except the ELF file associated with the build has all the debug symbols in it for debugging. So I'm going to build that with that -g, and I'm now going to build the firmware that Henry, so build this exact firmware that Henry was flying. And when it builds, it should build fairly fast because I built this one fairly recently. So I'm hoping that this will not be too long. So once this is built, I'll then show you how you can attach a debugger to the resulting build file to have a look at what went wrong in the flight, and then hopefully find the bug, and then open a PR to fix it, and then backport the PR to the stable release and, you know, go through our development process. But the first step is to see if we can work out why it crashed. So that's now done most of the build. Should be done in another 30 seconds or so. There it goes, and it's built. Now, it's built all the usual .bin files and APJ and hex, etc. But the key file we need is this one here. This, if I run file on it, you'll see that it's an ELF 32-bit LSB executable for ARM. This is the executable that we can use to do debugging. And notice it says with debug information and not stripped. That means it's got the information we need to be able to use it with attaching a debugger. So now we've got a little script under tools debug called GDB crash dump, and should be GDB _crash dump. All right, if I just run that, it gives you some help, and it's saying, very sparse help, I must admit, it's wanting the ELF file and then the crash dump file. So what I do is I give it the ELF file, which is build Maytech H765 build ArduPilot, and now I've got to give it the crash dump file that I got from Henry, or I could have got out of the log. So if he sent me the log file, I can use the file command in Mav Explorer and extract the crash dump as a file. So what I'm going to do now, Henry, and I've got this cd.bin, that's the one we extracted at the start of this little demonstration. So if I run this, then what it's going to do is load that crash dump, and it's successfully loaded it. And now now it's just normal GDB, right? I can't make it run things because this is a static state, so I can't execute anything. I don't even have the F765 flight controller, you know, here on my desk, but I can go and inspect the state. So what I'm going to do is go into the GDB text user interface, so it makes it a bit easier. That was Control XA, and we can see that it was crashing in this CRC call. And I'm just going to exit the text user interface and ask for a backtrace. So the backtrace shows us how it got here. So we were in the RCin thread. It was doing a timer tick. It was processing new input on the RCin thread. It was checking for data on an added UART, so Henry was using a serial port as opposed to pulse input. Then it was processing a byte of that input, and it was within the process byte function. And this function changed very recently. It had a rewrite. So we're already in an area that's very recent. And then it's in the function check frame, and then that was calling a CRC update. Now, so let's go back and where we were here, and we can see it's doing a little loop, right? And so we can have a look at some variables. So if we have a look at the variable called P, so P is at address 208.00000, and it's doing this little loop while P not equal to P end. And P end, notice that P end is earlier than P, right? So there's our red flag. So in other words, it's going to continue with this P and keep going until it's wrapped memory all the way around and come back again. So that means that we've somehow ended up with really nasty, essentially infinite loop. Now, I could have a look at the length variable, or I could try to. Unfortunately, this is still an optimized build because this was a production build for this board, and the compiler does a lot of optimization. So the suspicion with this is that maybe length was bad, right? But we can't look at length because the compiler had optimized it out. But what we can do is we go up a frame like this, and we can have a look at what it was passing in for the length. And it's got this underscore frame dot length -1. And let's have a look at what underscore frame dot length was. That was 0. All right, well, if you take underscore frame, if you take that and you subtract 1 from it and you pass it as a uint32, then you end up with, except I've managed to, let me just do it using the syntax that GDB will like, 4 billion. And so what's happened is it's a underflow when it's subtracting 1 as an unsigned number. So that means that length down in this one was going to be 4 billion, 4 gigabyte, which means it was trying to do a CRC over 4 gigabytes of memory. Now, the board doesn't have 4 gigabytes memory. It has, 500K or so of memory. So that means it would have gone past the end of memory and started trying to read into invalid address spaces. And A, it would have taken a long time. That could have caused a watchdog. B, and most likely, is it just hit an invalid address for the microcontroller, which will cause what's called a hard fault, and the CPU will reset. So this is a very serious bug for people running CRSF. So what we need to do is, now we know what's happening. We know somehow that frame length is ending up at 0. And that basically means that I didn't do a good enough job reviewing this PR. I think Andy was the one that did the PR, but we worked on it together. And we obviously didn't do a good enough job looking at the conditions under which this frame length can get passed through. And somehow we ended up with a frame length of 0 being acceptable. And the simple thing we can put in here is to have a minimum frame length. So what I'm going to do is go and add a check into this code. So we'll create a PR for this. Master, and so now we know what the bug is. We can go back to the master branch and PR, and this is going to be CRSF length check. And so libraries APRC protocol. So now it's just fixing this, and we're at line 281. And so what we need to do is, so we need to check some validity of this. We want to make sure it really covers it. So check frame is called exactly when. Check frame is called with when we could have a new frame, and that's the only time that check frame is called. And what we need to do is just mark this, say that this is an invalid frame. So we need to say that this is an invalid frame. So if frame.length and is less than, and what is the minimum frame length? Well, the minimum for this thing to be valid, this check here requires 2 bytes. So the simplest check is if it's less than 2. All right, now let's see if that covers all the cases. So the frame length and correct. Now, all right, we could actually put a stricter check in here. We could go and put a stricter check and make sure that the length is exactly the value we want. And if we wanted to do that, we could run it through our little test suite. So we've got a little RC test suite and make sure that it passes. So I'm going to go and build that test suite. So, and so we've got in this little examples, RC protocol test, WAF, target, example, RC protocol test, and it's probably examples. Yes, let's try. There you go. That'll build a little RC protocol test. What that will do is that will test all our different protocols and make sure they still work. It includes various CRSF tests, and that would allow me to check that this is coming out right. So I'll just build that, and then I'll run that test to make sure this change works. But I can also jump into the debugger and I can check that put a stricter check on that length. So I think it would be nice for us to do a stricter check to make sure that the length is equal to the frame offset. So I think what we want it to be is length plus CRSF header length equals all right now. Okay, so I'm using a lot of CPU. I'll just lower the number of CPUs I'm using while we're recording this, so it's not quite so slow, not quite so impactful on the recording. Let's see. Now we have to cope with the fact that there might be more bytes to come, and let's see, a frame.length. Let's see, plus that is less than frame offsets. I think that's probably the check to do. but we'll see if it passes our test suite. Now we're watching paint dry with the building. Any questions about this, Henry or Michelle? All right. So I think this is going to need to be to go out in 4.5.1. We'll need to get a beta out and get this fixed, because anyone running CRSF vulnerable, what would have happened, Henry, is you would have had some corrupt bytes coming in on that serial port, and those corrupt bytes could have then triggered this bug where it then, went too far. I'm going to have a look at some of the related protocols, because there's some similar. Okay, so I've managed to misspell CRSF. All right, I just had a typo. Yeah, so, but CRSF, we actually use the same driver for it, so that'll cover that one. Just having a look at some of the others that might use similar parsing and see if it's the place where it's, so CRSF, so this one here is a similar type of thing. Just whenever you get a bug like this, you want to make sure, yeah, that one's got the check. It's got a control length is greater than 2 in it, so that's all right. So Ghost protocol is somewhat similar. And so, okay, that one's got, that looks all right. So I might add a paranoid check in this. Frame dot length is, plus. Let's see. So overflow, yep. Now we want to check if the frame dot length could be too short. Okay, so I'll leave this one for the moment and come back to that one later during our code review. And so let's go and run this test. So we've ended up at this test here, and that test is test passed. Great. So with this change in place, that means that we're still correctly parsing CRSF, right? And this test, so that's all passing, good, no input, great. All right, great. So I think we're ready to create a PR for this. So APRC protocol, fixed CRC memory range error in CRSF. This fixes a crash bug that caused a watchdog for Henry on a F765-wing. The bug happens with corrupt serial data causing an underflow in the length argument to the CRC call. And then I will open the PR and put in a screenshot of the backtrace. And I'm going to set Andy as the reviewer. Great. And now, mark this up to make it blindingly obvious what's going on. And mark that as a bug. And put it in our backports. All right, so that's done that process. We will add it to dev call topic to discuss. We'll almost certainly get a release out very quickly. So I hope that helps people understand the process of finding bugs like this. Many thanks to Henry for reporting the issue. So if you have a crash dump.bin being reported, if it says you are logging a crash dump.bin, so that's this little message you get up in Mission Planner or your ground station saying logging sys crash dump.bin, don't just ignore it. Please do report it and get us a copy of that crash dump.bin. You can get that from multiple ways. You can use Mav Explorer, but there's also this hardware report tool that Pete Hall has done, which I believe has the ability to extract crash dump files. So I'm going to try that. I've never actually done that before, but let's see if that works. So come on, web browser. There it is. Okay. So I'm going to go into users, Henry there, and that log file. And up, it's okay. Try it again. And now finally, there it is. Okay, great. Now, I believe that there are the files. There it is, download files. And you can go crashdump.bin, and that has now downloaded that crashdump.bin file into my directory here. It's a not very useful way of preview, but that's now downloaded that. And so you may find this web tools way of downloading the file easier rather than installing Mav Explorer. And make sure you include the log file as well for us to analyze. All right, so that's about it. So enjoy flying ArduPilot. Please make sure you report any crash dumps that you run across, and that allows us to find the bugs and fix them like I've just shown you. Thank you all. Right, bye.